All right, let's get right into it. Day 16, part 1. Let's get the music going without it being too blasting. So I was looking at this a little bit more and getting my notes together, so hopefully I've got what I think is a decent solution. So here are all my notes. So basically we create this path which has all this information. We can have it tell us what the next paths are given the state of the map, and blah blah blah. So let me just go through this and start coding it up, and hopefully can actually get this to work. So yeah, a map item is just either the start or the end or the wall. So we got an array of those. Now a path is what? Actually, no, it's not a list of the number of traverse positions, because we don't need that. Number of turns, current position, no, direction, excuse me. And we also want it to have a method yeah, we can always just give it the map itself. Right? Because the map isn't, I was thinking maybe we could just pass it the map on construction, which is fine. I mean, it's just the same references everywhere. We have a map. Right now, they'll just return empty. But that's going to hold all the logic to say, here are the next paths. Okay. And so we want to create the first map or first path. So give it the map. And it hasn't traversed anywhere. We haven't turned anywhere. Its current position, well, we don't know. Direction is supposed to head east if I remember right. Facing east, yep. Current cost is 0. False, it hasn't finished. Okay. There. So now we know where the start is. And then we're going to say var Okay, so we say that's the one we're going to start. We're going to get the next ones. And so we say var okay. The thing I was thinking of is I want to do some things to get rid of paths if I know there's no point in continuing to evaluate them. But I don't think I need to worry about that. And the minimal cost we're going to say is, well, we can't say max value on a big integer. And maybe the right thing to do then down here is if then we evaluate it. If it's above, we don't care. Okay, so we get the next paths. And that can be 0 to 3, right? That's my notes. So the ones that are finished, we don't care about. So we want to say well, we want to see if there are any that are finished. No. So what does that give us? They'll either give us a null or a finished path. If finished next paths is strictly less than the minimal cost, then the minimal cost now equals that. And we don't have to check that because we know it's not null. So now we have there. So now we want to grab the ones new paths, add range from the next paths where not is finished and the current cost is strictly less than the minimal cost. There. That should work. So we go through the paths to evaluate, and we know that we don't have to worry about it being finished when we start. Is its current cost less than the minimal cost? Yes, although as we go through this, we might start finding paths that are finished and other paths that are still in flight. And when we try to evaluate again, we realize, well, their cost is already at or above, and there's no reason to keep trying to evaluate it. So it'll fall off the face of the map, or the earth, or whatever you want to call it. So we get all the next paths. We look for the minimal current cost for those that are finished. And if we find a case like that, then we set the new minimal cost. Then we get the other ones that are still cheaper. And we move on. And eventually, if we go through all this and we find finishes, we don't find any unfinished ones, paths to evaluate will eventually become 0 because we won't find any new paths. At least that's the hope. So we now have to implement this. And we want to basically do all the directions as long as it's not 180 from us. So, our new paths is going to be a new list of path. And then we're going to return that. So we're going to say we'll look east if we're not going west. Right, because if our direction is north, we'll look east. If it's east, we'll look east. If it's south, we'll look east. If it's west, we won't look east. Because we may not find one. Equals this dot current position x plus 1, and its position is the same y. Oh, x. And then we'll look at the next map item. If it's duh. Okay, so if we find a wall, we're not going to make a new map item. Well, we can say if it's null or next map item type is equal to the end, then we're going to make a new map item. This with the map will stay the same. Traverse position count will equal +1. The number of turns is equal to this number. If this current direction does not equal east, this number of turns +1. Whoops. Else this number of turns, because then we didn't turn. If we were facing north and we can go east, this new path will have turned. Get current cost. Let's not do that. Let's, because that's calculable, if that makes sense. Okay, number of turns. Current position is equal to this current position with X, our current position plus 1, because we're moving towards the east. Current direction is east. And is finished is false. We know that. Public long get current cost. What is the current cost? Current cost is this traverse position count plus 1,000 times the number of times returned. That's fine. Okay. Okay. So we're going to look east. We're going to see if there's something on the map that's east of us. If it's null, or if it's the end, oh. Yeah, because the only way it could not be null is because we found that we're at the end. The only other thing we could find is a wall. Well, we could find the start. I mean, and we should never cross back over the start. So that should be fine. Okay. So these are okay. Either we didn't find it or we found the end. The other thing we have to look for is a wall. If it's a wall, we just wouldn't create another map. So if it's null, we move ahead. Or it does not equal a wall, because start would be it doesn't equal a wall, but it's not an end, so we shouldn't care about that. It's not a wall, and it is the end. It is a wall, we just fall through. Okay, so now we have to do the same thing for west, east, south. Sorry. We're going to look east, we're going to look south. So direction in this case is not north. And to look south, same X, but its position has to be below us. If our current direction isn't south, there. East, no, I'm sorry. East, south. Now we want to look west. So this is saying we're not going east. To look west, we have to look that way. Oop, this is wrong. This will be X minus 1. And then we're going to look north. But, yeah, we have to do this for... This isn't an else if. This is each one of these. Because this will give us 3 every time. Because if we were looking south, we could look east. We could look south. We could look west. But now we're going to look north. So we wouldn't do this one. So this is the same X, but Y minus 1. Right? There, and that gets us all the new paths. Okay, let's review this real quick. If our current direction isn't west, we're going to look east. To look east, we have to do X plus 1. We update the traversed. The number of turns is, if our current direction isn't east, then we turned. Otherwise, it's the same. Our current position is now moving to the east. Our current direction is east. And did we finish? Right. And I'm assuming here, it may be a bad assumption, but I'm assuming here that we'll never run into the start again. We're always moving away from it. Okay. To look south, we can't be going north. That increases by 1. Same thing here. We can't be going north or south. Well, we turned, yeah. This is wrong. North. Excuse me. Wait, this is also wrong. East, east, south, south, west, west, north, north. Okay. West. We can't be looking east. It's behind us, behind us. Look north. Okay, I think, except we map, traverse positions, number of turns, current position. Oh, we took the costs off. That's right. We still have that as a property, but it's calculated. All right. So let's run some tests. Let's see how wrong we are. Really? Huh. All right. Let's head on over to the big test. Oh. Well, there was an attempt. The problem is that I can't see. I have no telemetry on this right now, so I can't see if I'm like what my iteration is, how many current values do I have. So I might need to add that in. Because otherwise I'll never know if this is just like spinning wildly out of control. Yeah, I don't know. Okay, so we have that. Oh, no, that wouldn't. That's being set to how many new ones we get. Yeah, unfortunately, this starts becoming unbearable. Well, It's interesting that you get that many. I mean, you'd start off with just 2. This one would die off pretty quickly. You can start to see, like, yeah, it starts exploding. I get why it's... Like, you hit these areas here. So obviously I'm missing an optimization. Obviously I'm missing an optimization. I was a little, excuse me, I was a little afraid of this. Yeah, we're already like getting up to 1 million, and I bet we haven't even gotten close to the end of the map. All right, we need to rethink this. I must be missing something easy. I mean, I'm doing it the easy way, the straightforward way, but it's not efficient at all. Well, I guess one thing to think of is, like, if I'm going to go north here, if I'm here, I don't have to give a new map for this, and a new map for, or path for this, and a new path for this. I could say I'm here, and in the direction I'm going, I keep going until I can't anymore. Along the way, if I find other branches, I can create those as other paths, which I won't evaluate, but I'll just say that's a potential next path. Now that doesn't, all that's going to minimize is, you know, going through this loop a number of times, because we get up to here and actually we'd never loop. A better example would be if I'm here and I'm facing down. Well, I would say if I'm here, you know, I can go north again. Great. If I'm here, I can go south again. 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 I hit this. Well, I can't go south, so that path is actually terminated, and I don't do that one anymore. But I can turn east. And so that's another one to evaluate. I I don't really know if that's going to give me a lot, though. I guess another way to think of it is if I'm here and I'm going down, what are all the possible new paths going this way? Well, there's only one. It's going east, which is what we would hit eventually. It's just we're trying to avoid returning this one as a new map. This one is a new map. You know what I mean? Like if I'm here, and I know I'm I don't really know if that gains us anything. And again, we can't just assume that the shortest path is the best path because turns are very, very costly. So it might be beneficial to find, like I said, if you did like this, that might be shorter than a map that might be longer than a map that does like this and then up. But there's so many turns in that thing that's much more costly. So you can't do that. It's really quick for the short maps, but that's not good enough. Right. I think algorithmically I've got like the right abstractions. It's just taking way too long. And I mean, I guess it's possible too. Like here. If I go this way and then you go up, this ends, you end up here the same if you would have ended up going up and around and over. This says 1, 2 turns. This says 1, 2 turns, but there's more. There is more cost, even though it's just based on this. In this case, if this ends up being the right path, going that way and then going up, coming over and down would be better than this all the time. I know there's that whole star path or a path or something like that. It's like, what's the quickest way to get through a maze? But again, in this case, you can't assume that the shortest path is the best path. You want the shortest path. You want the smallest cost path. Returns are highly discouraged. The less turns you can do, the better. Well, I'm kind of stuck. That does not mean I want a hint. It just means I'm stuck. I'm just curious. I want to run this and I want to say... There we go. Okay. How far are we actually getting? That's not what I wanted. So I'm only getting about 77 moves in and it just explodes. So yeah, it's really fast if you got a short map, but once you start getting a bigger map, this is not the right way to do it. And yeah, you could keep all the points, the positions that you did travel, because if you end up somewhere where you were before, you could say, well, it's just going to be more no matter what you do. So, because this one is going to keep going, this one would also keep going. They don't know, like, it doesn't know that it's any worse. And so it's contributing to the problem. But how many of those do you have? And does that actually make it worse? Like I could see here, maybe if you were coming up this way, like you have 3 paths to go, coming back, like going down, coming back here and coming back up is the same thing as just doing 2. That path is completely useless, but we're going to traverse it and go through it and continue on and exasperating the problem. It's the same thing too with this path. Going down here, coming up, over, left, up is the same as just going straight this way. And that's far more costly. Well, this is disappointing. I was hoping to do a stream and get this done. Though, like I said, I kind of had the feeling that, like, here's another one. This point currently would come up to here, but you could also end up having a path that goes all the way over here, comes up, over, down, over, up, over, and here. And that is a worthless path compared to that one. That one is gonna, again, it's gonna keep contributing the same in terms of computational cost, but there's no reason to evaluate that one and the paths it's going to generate because it could never be cheaper than the one that just went straight up. And so one thought would be is anytime you find a junction, so let's just write out the notes to this. Here's a thought. Again, this is just a thought. Anytime we find a junction, that is, we can go in more than one direction, like here, because if I come up to this, I notice I can go up and down. Well, and it's possible too that you could get to that junction quicker than another path, potentially, though highly unlikely. And you would end up having them fall off the face of the earth anyway. Right? I guess, again, the idea is if we're hitting a junction, like we're here and we're going to go west, this is no turns to get to here. But I could go down, over, up, over, down, over, up, and I hit that junction. And the cost of whatever this path was to get to here is far less than it would be to do this jump. So we can just stop that one. Right. I mean, I guess if you hit like a four-way, then maybe depending upon which way you're coming to it would matter too. But if your cost is strictly greater when you hit that junction, whether you would keep going straight or not doesn't matter. I don't know. I don't know if that feels like it could help, but I really don't know how much that is going to help. I mean, like something like this here, you have to go up, over, up, and then left and right, and then eventually you're going to see, well, yeah, I can't go anywhere. There are a couple things we can do to speed it up. I mean, a little bit. Like if I'm here and I'm going that way, I can just basically say, keep going that direction, keeping your count of how many positions you're moving. But notice that we never make a new path until we come here. Well, then we have to do the, now which way do I look? If we were here and we were moving east, you can do the same thing, except we get here. At every point you have to say, by the way, could I turn? Could this be a new path? And that's another one to evaluate. So I say, yep, new path starts going that way. And then we keep going this way until we can't anymore. That might make things better, but I'm not really sure. I do have a day job to start, so I'm going to get to that soon. I am disappointed that I was not able to finish this. I will say that. I wish I could have. But like I said, I think I was a little concerned with the size of the map, that I was just not going to complete it. And it was going to get just completely out of hand. I mean, if you saw that the maximum path I was getting through is 70, well, what is that? That's like this. I mean, that's just a straight character count over. But that just shows you how little my approach is getting through this. It's pathetic. So, yeah, I need to do the thing, and I am going to do the thing where I just need to walk away, let my brain noodle on this a little bit more, and think about what would actually help speed this up tremendously. And come back to this hopefully on Saturday. With that, I'm going to stop the stream. Thank you for watching, whether it's now or in the future. Please subscribe to the channel. I would greatly appreciate it. I don't want to hint just yet because I am still noodling on this. But if this gets to the point where I'm just completely stuck and I can't get this sped up, then I will be asking for help. So with that, thank you for watching. Take care, and I hope to see you in the future.